Hello, we are Itzel, Daniela, and Ricardo Raúl, and we are going to review Chapter 11, It's a Network. In this last chapter, we are going to learn how to assemble all the elements from the past chapters in a functioning network that can be maintained. With small networks, the design of the network is usually simple. The network topologies for small networks typically involve a single router and one or more switches. They may also have wireless access points and IP phones. As for connection to the internet, normally a small network has a single WAN connection provided by DSL, cable, or an Ethernet connection. The majority of work is focused on maintenance and troubleshooting of existing equipment, as well as securing devices and information on the network. One of the first design considerations when implementing a small network is the type of intermediate devices to use to support the network. These are a number of factors that need to be considered: the cost, speed and types of ports or interfaces, expandability, and operating system features and services. When implementing a small network, it is necessary to plan the IP addressing space. All hosts within an internetwork must have a unique address. Examples of different types of devices that will factor into the IP design are end devices for users, servers and peripherals, hosts that are accessible from the internet, and intermediary devices. Planning and documenting the IP addressing scheme helps the administrator to track device types. Additionally, administrators are better able to control access to resources on the network based on IP address when a deterministic IP addressing scheme is used. Each of these different device types should be allocated to a logical block of addresses within the address range of the network. Redundancy helps to eliminate single points of failure, and this can be accomplished by installing duplicate equipment or duplicating network links for critical areas. The smaller the network, the less the chance that redundancy of equipment will be affordable. Therefore, a common way to introduce redundancy is through the use of redundant switch connections between multiple switches on the network and between switches and routers. Users expect immediate access to their emails and to the files that they are sharing or updating. To help ensure this availability, the network designer should take the following steps. Step 1. Secure file and mail servers in a centralized location. Step 2. Protect the location from unauthorized access by implementing physical and logical security measures. Step 3. Create redundancy in the server farm that ensures if one device fails, files are not lost. Step 4. Configure redundant paths to the servers. In addition, the network administrator should consider the various types of traffic and their treatment in the network design. In fact, a good network design will classify traffic carefully according to priority. Traffic classes could be as specific as file transfer, email, voice, video, messaging, and transactional. The network is only as useful as the applications that are on it. There are two forms of software programs or processes that provide access to the network: network applications and application layer services. Network applications are the software programs used to communicate over the network. Email clients and web browsers are examples of this type of application. Application layer services are other programs may need the assistance of application layer services to use network resources, like file transfer or network print spooling. Network protocols support the applications and services used by employees in a small network. Common network protocols include DNS, Telnet, IMAP, SMTP, POP, DHCP, HTTP, FTP. Each of these network protocols defines processes on either end of a communication session, types of messages, syntax of messages, meaning of informational fields, how messages are sent and the expected response, and interaction with the next lower layer. Modern businesses, even small ones, typically use real-time applications for communicating with customers and business partners. Real-time applications require more planning and dedicated services to ensure priority delivery of voice and video traffic. This means that the network administrator must ensure the proper equipment is installed in the network and that the network devices are configured to ensure priority delivery. To transport streaming media effectively, the network must be able to support applications that require delay-sensitive delivery. Real-time Transport Protocol (RTP) and Real-Time Transport Control Protocol (RTCP) are two protocols that support this requirement. RTP and RTCP enable control and scalability of the network resources by allowing quality of service (QoS) mechanisms to be incorporated. These QoS mechanisms provide valuable tools for minimizing latency issues for real-time streaming applications. A network administrator for a small network will either work reactively or proactively. To scale a network, several elements are required: network documentation, device inventory, budget, and traffic analysis. While the network administrator will have more time in a small network environment to individually analyze network utilization for each network-enabled device, a more holistic approach with some type of software or hardware-based protocol analyzer is recommended. Information gathered by the protocol analyzer is analyzed based on the source and destination of the traffic as well as the type of traffic being sent. This analysis can be used to make decisions on how to manage the traffic more efficiently. A network administrator in a small network has the ability to obtain in-person IT snapshots of employee application utilization for a significant portion of the employee workforce over time. These snapshots typically include information such as OS plus OS version, not network applications, CPU utilization, drive utilization, and RAM utilization. Documenting snapshots for employees in a small network over a period of time will go a long way toward informing the network administrator of evolving protocol requirements and associated traffic flows. Intruders who gain access by modifying software or exploiting software vulnerabilities are often called hackers. After the hacker gains access to the network, 4 types of threats may arise: information theft, identity theft, data loss manipulation, and disruption of service. The 4 classes of physical threats are hardware threats, environmental threats, electrical threats, and maintenance threats. 3 network security factors are vulnerability, threat, and attack. Vulnerability is the degree of weakness which is inherent in every network and device. Threats include the people interested and qualified in taking advantage of each security weakness. Threats are realized by a variety of tools, scripts, and programs to launch attacks against networks and network devices. There are 3 primary vulnerabilities or weaknesses: technological, configuration, and security policy. Malicious code attacks include a number of types of computer programs that were created with the intention of causing data loss or damage. The 3 main types of malicious code attacks are viruses, Trojan horses, and worms. A virus is malicious software that is attached to another program to execute a particular unwanted function on a workstation. The key element that distinguishes a computer worm from a computer virus is that human interaction is required. A Trojan horse is different only in that the entire application was written to look like something else, when in fact it is an attack tool. Worms are self-contained programs that attack a system and try to exploit a specific vulnerability in the target. The anatomy of a worm attack is as follows: the enabling vulnerability, propagation mechanism, and payload. Network attacks can be classified into 3 major categories: reconnaissance attacks, the unauthorized discovery and mapping of system services or vulnerabilities like we can see in the video; access attacks, the unauthorized manipulation of data, system access, or user privileges; and denial of service, the disabling or corruption of network systems or services. Antivirus software can detect most viruses and many Trojan horse applications and prevent them from spreading in the network. Antivirus software can be deployed at the user level and at the network level. The most effective way to mitigate a worm attack is to download security updates from the operating system vendor and patch all vulnerable systems. Authentication, authorization, and accounting. AAA network security services provide the primary framework to set up access control on a network device. AAA is a way to control who is permitted to access a network what they can do while they are there, and to watch the actions they perform while accessing the network. AAA provides a higher degree of scalability than the console, AUX, VTY, and privileged exec authentication commands alone. A firewall is one of the most effective security tools available for protecting internal network users from external threats. A firewall resides between two or more networks and controls the traffic between them, and also helps prevent unauthorized access. Firewall products use various techniques for determining what is permitted or denied access to a network. These techniques are packet filtering, application filtering, URL filtering, and stateful packet inspection. Firewall products come packaged in various forms: appliance-based firewalls, server-based firewalls, integrated firewalls, and personal firewalls. Securing the internal network is just as important as securing the perimeter of a network. The internal network is made up of network endpoints. An endpoint or host is an individual computer system or device that acts as a network client. Common endpoints are laptops, desktops, servers, smartphones, and tablets. If users are not practicing security with their endpoint devices, no amount of security precautions will guarantee a secure network. When a new operating system is installed on a device, the security settings are set to the default values. In most cases, this level of security is inadequate. There are some simple steps that should be taken that apply to most operating systems. Default usernames and passwords should be changed immediately. Access to system resources should be restricted to only the individuals that are authorized to use those resources. Any unnecessary services and applications should be turned off and uninstalled when possible. To protect network devices, it is important to use strong passwords. Here are standard guidelines to follow. Use a password length of at least 8 characters, preferably 10 or more characters. Make passwords complex. Avoid passwords based on repetition, common dictionary words, letter or number sequences, usernames, relative or pet names, biographical information such as birth dates, ID numbers, ancestor names, or other easily identifiable pieces of information. Deliberately misspell a password, change passwords often, and do not write passwords down and leave them in obvious places such as on the desk or monitor. When implementing devices, it is important to follow all security guidelines set by the organization. This includes naming devices in a fashion that allows for easy documentation and tracking, but also maintains some form of security. It is not wise to provide too much information about the use of the device in the hostname. Strong passwords are only as useful as they are secret. There are several steps that can be taken to help ensure that passwords remain secret. Using the global configuration command, service password encryption, prevents unauthorized individuals from viewing passwords in plain text in the configuration file. This command causes the encryption of all passwords that are unencrypted. Additionally, to ensure that all configured passwords are a minimum of a specified length, use the security passwords min length command in global configuration mode. A banner message is similar to a no trespassing sign. Be sure banner messages comply with security policies for the organization. Another recommendation is setting executive timeouts. By setting the exec timeout, you are telling the Cisco device to automatically disconnect users on a line after they have been idle for the duration of the exec timeout value. Exec timeouts can be configured on console, VTY, and aux ports. The legacy protocol to manage devices remotely is Telnet. Telnet is not secure. Data contained within a Telnet packet is transmitted unencrypted. Using a tool like Wireshark, it is possible for someone to sniff a Telnet session and obtain password information. For this reason, it is highly recommended to enable SSH on devices for secure remote access. It is possible to configure a Cisco device to support SSH using 4 steps as shown in the figure. After the network has been implemented, a network administrator must be able to test the network connectivity to ensure that it is operating appropriately. Using the ping command is an effective way to test connectivity. A ping issued from the iOS will yield one of several indications for each ICMP echo that was sent. The most common indicators are exclamation mark that indicates receipt of an ICMP echo reply message, a dot that indicates a time expired while waiting for an ICMP echo reply message, and a capital U, an ICMP unreachable message was received. The ping command is used to verify the internal IP configuration on the local host. This verifies the proper operation of the protocol stack from the network layer to the physical layer and back without actually putting a signal on the media. The Cisco iOS offers an extended mode of the ping command. This mode is entered by typing ping in privileged exec mode without a destination IP address. Entering a longer timeout period than the default allows for possible latency issues to be detected. If the ping test is successful with a longer value, a connection exists between the hosts, but latency may be an issue on the network. One of the most effective tools for monitoring and troubleshooting network performance is to establish a network baseline. A baseline is a process for studying the network at regular intervals to ensure that the network is working as designed. A trace returns a list of hops as a packet is routed through a network. When performing the trace from a Windows computer, use tracer. When performing the trace from a router, CLI, use traceroute. Like ping commands, trace commands are entered in the command line and take an IP address as the argument. The Cisco iOS CLI show commands display relevant information about the configuration and operation of the device. The show commands are available whether the device was configured using the CLI or Cisco Configuration Professional. The status of nearly every process or function of the router can be displayed using a show command. Some of the more popular show commands are show running config, show interfaces, show ARP, show IP route, show protocols, and show version. After the startup configuration file is loaded and the router boots successfully, the show version command can be used to verify and troubleshoot some of the basic hardware and software components used during the boot up process. The output from the show version command includes the Cisco iOS software version being used, the version of the system bootstrap software stored in ROM memory that was initially used to boot the router, the complete file name of the Cisco iOS image and where the bootstrap program located, type of CPU on the router and amount of RAM, the number and type of physical interfaces on the router, the amount of NVRAM, the amount of flash memory on the router, and the currently configured value of the software configuration register in hexadecimal. The show version command on a switch displays information about the currently loaded software version, along with hardware and device information. Some of the information displayed by this command is software version, bootstrap version, system uptime, system restart info, software image name, switch platform and processor type, memory type, hardware interfaces, and configuration register. The IP address of the default gateway of a host can be viewed by issuing the ipconfig command. A tool to examine the MAC address of our computer is ipconfig all. The ipconfig display DNS command displays all of the cached DNS entries on a Windows computer system. The ARP command enables the creation, editing, and display of mappings of physical addresses to known IPv4 addresses. ARP-A command lists all devices currently in the ARP cache of the host, which includes the IPv4 address, physical address, and the type of addressing, static or dynamic, for each device. The cache can be cleared by using the ARP-D command in the event the network administrator wants to repopulate the cache with update information. CDP is a Cisco proprietary protocol that runs at the data link layer. When a Cisco device boots up, CDP starts up by default. CDP automatically discovers neighboring Cisco devices running CDP. CDP exchanges hardware and software device information with its directly connected CDP neighbors. CDP provides the following information about each CDP neighbor device: device identifiers, address list, port identifier, capabilities list, and platform. To disable CDP globally, use the global configuration command no CDP run. To disable CDP on an interface, use the interface command no CDP enable. One of the most frequently used commands is the show IP interface brief command. This command provides a more abbreviated output than the show IP interface command. It provides a summary of the key information for all the network interfaces on a router. The show IP interface brief command can also be used to verify the status of the switch interfaces. The switch can also test its layer 3 connectivity with the show IP interface brief and trace route commands. It is important to keep in mind that an IP address is not required for a switch to perform its job of frame forwarding at layer 2. An IP address is only necessary if the switch will be managed over the network using Telnet or SSH. If the network administrator plans to remotely connect to the switch from a location outside of the local LAN, then a default gateway must also be configured.
Configuration files are important in cases where a device presents a failure because backup and information retrieval depend on the proper management of the configuration files. The Cisco iOS file system provides a single interface to all the file systems a router uses, including flash memory file systems, network file systems, and any other endpoint for reading or writing data, such as non-volatile RAM, read-only memory, among others. Cisco iOS allows the administrator to move around to different directories and list the files in a directory and to create subdirectories in flash memory or on a disk. The command show file system provides useful information such as the amount of available and free memory, the type of file system, and its permissions. Permissions include read-only, write-only, and read-on-write. There are two very important file systems in a router. First, the flash file system. There are several files located in flash, but the most important one is the current Cisco iOS file image that is currently running in RAM. Then we have the non-volatile RAM file system. Once you are in the non-volatile RAM directory, the pwd command, which stands for present working directory, verifies that you are effectively in the non-volatile RAM directory. Just like the flash file system, there are many files listed, but the one of most important is the startup configuration file. The switch file systems are very similar to the file systems of a router. The command to view the file systems on a Catalyst switch is the same as on a Cisco router, being show file systems. Cisco switches support many basic Unix commands, such as cd for changing directory, dir to display directories on a file system, and pwd to display the working directory. Backing up a device's data is crucial in order to reduce the downtime of a network as well as avoiding the loss of any information. One way to back up is to a text file. Configuration files can be archived to a text file using Teraterm. Files like these can be used to restore a system by posting the text into a terminal window. The iOS will treat each line of the text as a command. This means that the file will require editing to ensure that encrypted passwords are in plain text and that non-command text and iOS messages are removed. Another method for backing up is using the trivial file transfer protocol. Copies of configuration files should be stored as backup files in the event of a problem. Configuration files can be stored on a trivial file transfer protocol server or a USB drive. A configuration file should also be included in the network documentation. The USB storage feature provides an optional secondary storage capability and an additional boot device. Images and configurations can be copied to or from the Cisco USB flash memory with the same reliability as storing and retrieving files using the compact flash card. By the way, to be compatible with a Cisco router, a USB flash drive must be formatted in a FAT16 format. When backing up to a USB port, it is recommended to use the show file systems command to verify that the USB drive is there and to confirm the name. Using the copy run command followed by the USB drive's name, the configuration file will be copied to the desired drive. The USB drive's name has to match the name that was displayed when the show file systems command was issued. The router will prompt the user for a file name, and if the file is already present in the USB flash drive, the user will be prompted for overwriting said file. In order to copy the file back to the router, a text editor will be needed to make sure that the configuration file copied in the USB is a valid configuration file. This is because there are a lot of entries in the file that are not valid commands, and no interfaces will be brought up. Networks are not exclusive to companies, and home networks have been taking advantage of the networking technology. Home networks are similar to those of small businesses, and they both share the need of small volume devices, unlike big companies' dedicated routers and switches. Smaller scale devices, as long as they provide the same functionality of routing and switching, are all that is needed. This is where multifunction devices, referred to as integrated routers, come in. An integrated router is like having several different devices connected together, like a router connects to a switch, but it is all done internally. For example, if a packet is addressed to a device on the local network, the internal switch will forward the packet to the destination device. And if a packet is addressed to a device on a remote network, the internal switch will forward the packet to the internal router, which will then determine the best path and forward the packet accordingly. Most integrated routers offer both wire switching capabilities and wireless connectivity, and they serve as an access point in the wireless network. Wireless connectivity is a popular, flexible, and cost-effective way for homes and businesses to provide network services to end devices. Additional features of some integrated routers include this DHCP service, a firewall, and even network-attached storage services. As every other medium available in the market, wireless has its own advantages and limitations. In the side of advantages, we have mobility, which allows for easy connections of both stationary and mobile clients. Scalability, easily expanded to allow more users to connect and increase the coverage area. Flexibility, provides connectivity anytime and anywhere. Cost saving, equipment costs continue to fall as technology matures. Reduced installation time, with just a single piece of equipment, a large number of people can achieve connectivity. And reliability in harsh environments. Easy to install in emergency and hostile environments. Now, the limitations of wireless include interference. Wireless technology is susceptible to interference from devices that produce electromagnetic energies, such as cordless phones, microwaves, or TVs. Network and data security. Wireless purpose is to provide connectivity, not security. It can expose wire networks by adding an access point. And technology-wise, wireless hasn't reached the speed nor the reliability of wired LANs. Integrated routers can satisfy the needs of a home office or a small business with a small device, or up to an entire enterprise branch offices with a more heavy-duty oriented device. The Linksys wireless router, intended for small networks, is simple in design and does not typically have separate components. This reduces the cost of the device, but in case of failure, replacement of a single failed component is not possible. The Cisco Integrated Service Router product family covers the need of a small office or a home office as well as those of larger networks. Many of the Cisco Integrated Service Routers offer modularity and have separate components for each function, such as a switch component and a router component. All integrated routers allow for basic configuration settings such as passwords, IP addresses, and DHCP settings. However, if using the wireless functionality, additional configuration parameters are required, such as setting the wireless mode, SSID, and the wireless channel. The wireless mode refers to setting the IEEE 802.11 wireless standard that the network will use. There are 4 amendments to the IEEE 802.11 standard that describe different characteristics for wireless communication. They are 802.11a, 802.11b, 802.11g, and 802.11n. Most integrated service routers support 802.11b, 802.11g, and 802.11n. These 3 technologies are compatible, but all the devices on the network must operate at the same standard common to all devices. For example, if an 802.11 router is connected to a laptop with the same protocol, the network will function as an 802.11n standard. However, if we add an 802.11b printer and the entire network will revert to the same slower 802.11b standard. This should be kept in mind when deciding to keep all their devices in a wireless network. The SSID, or Service Set Identifier, is a case-sensitive alphanumeric name for your home wireless network. It can be up to 32 characters in length. All devices in a wireless LAN must be configured with the same SSID in order to communicate. The wireless channel are channels created by dividing the available radio frequency spectrum. Each channel is capable of carrying a different conversation. Multiple access points can function in close proximity to one another as long as they use different channels for communication. Security measures should always be planned when connecting the access point to the network or ISP. Basic security measures include changing default values for the SSID, usernames, and passwords, disabling SSID broadcasting, configure encryption using WEP or WPA. WEP, which stands for Wired Equivalency Protocol, is an advanced security feature that encrypts network traffic as it travels through the air. WEP uses pre-configured keys to encrypt and decrypt data. A WEP key is generally a 64 or 128 bits long string of characters. In some cases, 256-bit keys are supported. To simplify creating and entering these keys, many devices include a passphrase option. For WEP to function, the access point, as well as every device on the network, must have the same WEP key entered. Without this key, transmissions can't be understood. The key is always the same, and there are many available applications on the internet devoted to find these keys. One way to overcome this vulnerability is to change the key frequently, but it is recommended to use the Wi-Fi Protected Access Encryption Format, or WPA. WPA also uses encryption from 64 to 26 bits long keys, but unlike WEP, WPA generates new, dynamic keys each time a client establishes connection with the access point. If a person wants to go further in protecting the security of a network, additional security implementations can be configured, such as MAC address filtering, authentication, and traffic filtering. In order to be able to configure all these options in an integrated service router, a computer must be connected to one of the Ethernet LAN ports in the back of the router. The computer will obtain the information necessary for its own IP addressing. If the connection was successful, by typing the computer's default gateway address, which is also the router's IP address, into a web browser, we provide access to the web-based configuration GUI. Enabling wireless. First, the correct wireless mode should be selected. Each mode includes a certain amount of overhead, so selecting the one that fits all devices will reduce the mentioned overhead. This also increases the security by forbidding devices using other standards to connect. Next, the SSID. For security purposes, the default SSID should be changed, as well as to allow the detection of the wireless LAN with easiness by the client. Disabling the SSID broadcast will mean that the client needs to manually enter this value. The radio frequency channel should be decided while considering networks nearby to avoid overlapping. Some access point can automatically locate the least congested channel. Finally, select the encryption mechanism desired and enter a key and passphrase. For a client to be able to connect with the router, values like the SSID, security settings, and channel information must match. To verify the connection between client and access point, the wireless link information screen of the Linksys software displays info like data rate and connection status. In order to meet user requirements, even small networks require planning and design. Planning ensures that all requirements, cost factors, and deployment options are given due consideration. An important part of network design is reliability, scalability, and availability. It is a necessity to consider security threats and vulnerabilities when planning a network implementation. All network devices must be secured. This includes routers, switches, end-user devices, and even security devices. Networks need to be protected from malicious software such as viruses, Trojan horses, and worms. Antivirus software can detect most viruses and many Trojan horse applications and prevent them from spreading in the network. The most effective way to mitigate a worm attack is to download security updates from the operating system vendor and patch all vulnerable systems. Networks must also be protected from network attacks. Network attacks can be classified into three major categories: reconnaissance, access attacks, and denial of service. After the network has been implemented, a network administrator must be able to monitor and maintain network connectivity. There are several commands available towards this end. For testing network connectivity to local and remote destinations, commands such as ping, telnet, and traceroute are commonly used. The use of networking is not limited to small businesses and large organizations. Another environment that is increasingly taking advantage of networking technology is the home. A home network is very similar to a small business network. However, most home networks and many small business networks do not require high volume devices, such as dedicated routers and switches. Instead, most home networks use a single multifunction device. For the purpose of this course, multifunction devices will be referred to as integrated routers. Most integrated routers offer both wire switching capabilities and wireless connectivity, and serve as the access point in the wireless network. To enable wireless connectivity, the wireless mode, SSID, radio frequency channel, and any desired security encryption mechanism must be configured.